Have you ever stopped to think about how your phone charger just knows which way to send power? Or, how pretty much any of your electronics work at all? Well, it turns out it all comes down to a really fundamental rule, a kind of one-way street for electricity that is absolutely essential for our modern world. So let's figure out how we direct all that traffic.
So, here's the plan for this explainer. First, we're going to get our heads around this idea of an electric one-way street. Then, we'll learn how to read the super simple diagram that makes it all happen. After that, we are going to unlock the secret to actually getting the electricity to flow. And finally, we'll see why this one little circuit is, frankly, a huge deal in our everyday lives.
All right, take a look at this. I know, it might not look like much, just a few lines and a triangle, but this is basically a map. It's the blueprint for controlling electricity. And believe it or not, a version of this is hiding inside pretty much everything you own that has a plug or a battery. So what on earth is it telling us?
Okay, so to read this map, we first have to understand the landscape it's trying to manage, which is the naturally chaotic, go-anywhere flow of electricity. We need to bring some order to that chaos.
This right here is the key. You see, electricity isn't picky. Left to its own devices, it would happily go every which way. But for our gadgets to work, we have to play traffic cop. We need to create a one-way street. And this circuit, this is exactly how we do it. It tells the current precisely where to go, and maybe even more importantly, where it is not allowed to go.
All right, let's learn the language of this map. We're going to decode this thing piece by piece, and we'll start with the most important symbols in the legend. Okay, look closely at that triangle with the line right at its point. This little guy is the absolute star of our show. Think of it as the gatekeeper, the bouncer at the club, the one-way valve that makes this entire thing possible.
And that gatekeeper has a name. It's a diode. Its job is incredibly simple, but also incredibly powerful. It lets electricity flow through in the direction that the triangle is pointing, but it slams the door shut if the current tries to come back the other way. It's the perfect little one-way sign for our electric street.
Now, for traffic to actually move down our one-way street, it needs a push, right? It needs an engine. In our diagram, that engine is this symbol over here with the long and short lines. This is our power source.
We call this a voltage source. That's just the technical term for the battery or the power supply. Its job is to provide the electrical pressure, the voltage, that actually pushes the current and gets it moving around the circuit. Simple, right? No push, no flow.
So, we've got our gatekeeper, the diode, and we've got our engine, the voltage source. But here's the trick. Just having them both in the circuit isn't enough. We have to connect them in a very specific way to get that gate to open. And that's the secret we're here to talk about. It's called forward bias.
Forward bias is really just the secret password. It's the correct way to hook up the battery to the diode to get it to say, all right, you can pass. If you connect it the wrong way, that gate stays shut. So the big takeaway here is that orientation, it's everything.
And this slide gives us the exact recipe. See the long line on the battery symbol? That's the positive side. You connect that wire to the flat base of the diode's triangle. That's called the anode. Then you take the short line on the battery, the negative side, and connect that to the line at the triangle's point, which is called the cathode. So positive to anode, negative to cathode. The moment you make that connection, click. The gate swings right open and the current starts to flow.
So let's look at our map one more time. Now it all makes sense, right? You can see the positive end of the battery is connected to the flat side of the diode. The current flows right through that now open gate, makes its way around the rest of the circuit, and returns back to the negative end of the battery. We have a complete, perfectly working one-way street.
And just to make this crystal clear, what if we flip that battery around? Well, that would be something called reverse bias, and the diode would completely block the flow. So the easiest way to think of it is this. Forward bias is the on switch. Reverse bias is the off switch. It really is that simple. Okay, so we get the concept. It's an on-off switch for a one-way street. But why does that matter so much? Well, because this isn't just some neat little textbook trick. This is literally the foundation for almost all modern electronics.
And this is where it all comes together. You know the power from your wall outlet? That's AC, or alternating current. It flows back and forth like crazy. But your laptop and your phone, they need DC, direct current, which flows in one steady direction. And that conversion from AC to DC, that's made possible by diodes in a forward-biased setup. They also protect your expensive stuff if you accidentally plug a power cord in backwards. Oh, and every single LED light? Well, an LED is just a special kind of diode that lights up when it's in, you guessed it, forward bias. This isn't some obscure principle. It's everywhere.
So the next time you plug in your phone or just see an LED light flicker on, remember that simple little one-way street. It really makes you think, doesn't it? Without these basic rules of the road, without the ability to tell electricity exactly where to go, what parts of our digital world just wouldn't exist?